When you're working on an electronics project, choosing a resistor seems like the easiest thing in the world, right? You just figure out the value you need, find the cheapest one, and you're good to go. But have you ever stopped to wonder, if it's really that simple, why on earth are there so many different kinds?
Okay, so let's dive right into that question. We're going to start with the absolute fundamentals. Then we'll see what resistors actually do inside a circuit. We'll explore all the different types, learn how to crack that color code, and finally, we'll get into the pro-level stuff, the specs that make all the difference.
So this is it. This is the central mystery we're going to solve today. It's what separates just knowing about electronics from really understanding electronic design. And by the end of this, you are going to have the answer.
But before we can appreciate all that variety, we have to get a really solid grip on a resistor's main job. So let's start at the very beginning.
At its heart, a resistor is just a current controller. And the best way to think about it is the classic water hose analogy. Imagine electricity is water flowing through a hose. Well, a resistor is like pinching that hose. You're creating a constriction that limits how much water, or in our case, current, can get through. It really is that straightforward.
Now the math behind this is the famous Ohm's law. V equals I times R. Voltage equals current times resistance. This is the absolute bedrock equation for pretty much everything we do with resistors. It's the tool we use to calculate exactly what's happening in our circuit.
Okay, so we know what a resistor is, but what does it actually do? You'd be amazed how many different jobs this one little component can have inside a circuit.
Resistors are the true workhorses of electronics. They can be used to create specific voltages as potential dividers, they help set up transistors to work properly, and they're crucial for setting the gain on amplifiers. But a really common one you'll see everywhere is current limiting for an LED. You know, that tiny little resistor is the only thing stopping that LED from burning out instantly. It's what controls its brightness.
And this brings us right back to our big question. Because all those different jobs have different demands, we need different types of resistors. This is where all that variety comes from. It's about finding the right tool for the job.
The first big divide is between fixed and variable resistors. Fixed resistors, just like the name says, have one set value and that's it. But variable resistors, which we often call potentiometers or pots, let you actually change the resistance, usually by turning a knob. If you've ever turned a volume dial on a stereo, you've used a potentiometer.
Now this is where it gets really interesting. The material a resistor is made from gives it a completely unique personality. Metal film resistors? Those are your reliable, low-noise, everyday choice. They're great for general-purpose stuff and precision work. But if you need to handle a lot of power, like in a big power supply, you'll need a big, beefy wire-wound resistor that can handle the heat. And for high-frequency circuits where you have to worry about other electrical effects, the low inductance of a carbon film resistor makes it the perfect choice. It's all about trade-offs.
Okay, so you've picked a resistor, but how do you know its value just by looking at those little colored stripes? Well, it's time to crack the famous Resistor Colour Code. It might look a little intimidating, but trust me, it's actually pretty simple.
So here's how you read a standard 4-band resistor. First, find the gold or silver band. That's your tolerance. You want to put that on the right side. Then, reading from the left, the first two colored bands give you the first two digits of your value. The third band tells you the multiplier, which is just a fancy way of saying how many zeros to add. And that last band on the right, that tells you how precise the resistor's value is.
So let's run through a quick example. Say you have a resistor with bands that are red, red, orange. Okay, so red is the number 2. That means our first two digits are 22. The third band is orange, which means a multiplier of 1,000, or 3 zeros. So we take our 22, we add 3 zeros, and we get 22,000 ohms, or what we'd normally call 22 kiloohms. See? Simple.
So knowing the resistance value is great for a hobby project. But when you're building a commercial product, something that has to be reliable for years, engineers have to look at a much deeper set of specifications.
And really, this is the big difference. A simple project might work just fine with any old 22K resistor you have lying around. But a mission-critical device needs a 22K resistor that can handle temperature changes, that won't drift over time, and that won't introduce electrical noise. That's where these secondary specs come into play.
You'll start to see specs on datasheets that look like this, plus or minus 50 ppm/K. This is the temperature coefficient of resistance, or TCR. All it's telling you is how much the resistor's value will change for every degree of temperature change, and that ppm just means parts per million.
So,
why does that even matter? I mean, 50 parts per million sounds tiny, right? Well, that seemingly tiny change can have a huge impact. In a precision circuit, like one using a 12-bit analog-to-digital converter, that little bit of drift from temperature could be enough to throw off your final reading by 5 whole steps. That's a massive error that could completely ruin your design.
And it doesn't even stop there. Engineers also have to worry about stability over time. We call it aging. They have to ask, how well does this thing get rid of heat? How much electrical noise does it generate all by itself? And how does its behavior change when we start dealing with really high frequencies? All of these factors are absolutely critical for a robust, professional design.
So we come all the way back to the beginning. Is a resistor just a simple component, or is it a precision instrument with a complex personality? Well, now you know the answer. It's both. And the next time you see one, you'll understand all the deep engineering that's hidden inside that tiny little package.